Hey guys, okay, so I'm gonna do the first case study on a MacBook, just kind of show you what to do. And then I'll also do it on a PC to show you that it does give you the correct values. So this is mainly just for the fact of showing you how to do it. So we're given that this is uniform distribution, how to calculate your expected value and variance. And we're given a sample size of 50 and a seed value of 123. So what we're going to do is we're going to go to the data, the ribbon, we're going to say data analysis, we're going to say random number generation, click OK. So our number of random numbers, that's 50. We want a uniform distribution. And we're given between 120 and 152. Our random seed is 123. Then output range, let's see where this. We're gonna put this. Yeah, let's put it over there. We're gonna say okay. So we want the X bar. So we're gonna say equals average. Select the data, and there we go. For the variance equals var.s. Select the column. There you go. So obviously this isn't the correct value as seen what's given to us, but this is just for the fact, as I said, to show you how to do it. So basically you're going to do the exact same thing. You're going to go to the data tab, you're going to go to data analysis, and you're going to put in random number generation, and you're going to get your values. Obviously you're going to calculate the average, which, yeah, put in the formula, select the data, press enter. Same thing with the variance, you're going to type in the formula, and you're going to select the data and also press enter. And then you've got the correct values. So for case study 2, it's about normal distribution. I put in a little definition here, so you're welcome to pause the video and just quickly have a read at it. Then we're going to use the formulas .dist and .inv. So for dist, it's basically calculating a probability for a given value of x, and inv is calculating a value x for a given probability. This table basically just shows you when to use what formula, which are these ones, when, for instance, which value is under consideration, and whether you want to calculate probability or an observed value. Also, the idea will always be to calculate a cumulative probability for which the cumulative criteria in the function needs to stay true. I'll show you this now in one of the examples. So with these examples, the first one states, calculate the following probabilities and z-scores from a standard normal distribution. So here we've got z smaller than or equal to 2. This is obviously our formula, but just show you how to actually type it in and then what you're going to get. So we're going to say norm.s.dist. It's this one. And we want 2. So we're going to say 2. And it's always true. There we go. Then for the next one, we want a z-score with a probability of 0.1 in the upper tail. We're going to say equals to 1 minus norm.s.inv. And we're going to say 0.1 because that's what we want. And there we go. For the second question, they ask us to calculate the following probabilities and x values from a normal distribution with an average of 110 and a standard deviation of 20. So here they ask us z for smaller than or equals to 90. Here's our formula, but I'm going to say equals norm.dist. Our x value is 90. Our mean is 110. Standard deviation is 20, and we're going to say true. And then for an x value with a probability of 0.5 in the lower 0.05 in the lower tail, I'm going to say equals norm.inv. Our probability is 0.05. Our mean is 110, and our standard deviation is 20.